Before I forget, I just want to raise the stiffness here on the ragdoll constraints, and also on the agent constraint network, the bias factor I think I want to look at. Let me just check. Not the bias factor, sorry, the constraint force mixing. Yeah. No, sorry, the bias, excuse me. The bias factor, yeah, I'm going to push that up to 8 so that the agents try to hold, you know, the joints stay within their limits a bit stronger. It is, you know, they do recommend up to 5, but I feel like we need to push it up a bit there. Okay, so I'm going to jump back inside here, and I'm just going to give this a name, main, because these are the main forces. Okay, and then I'm going to add another curve force on top of this one, and this one is going to be main just suction, right? So it's just to pull in the agents at the bottom. So call it suction just so we're clear. The same, I'll just copy the roots there, be lazy. Okay, and let's see, so the size, I want the size to be much bigger with this one, right? So the max influence radius will be 30. As you can see that, way bigger. Probably, yeah, we're not going to be pulling in agents from all the way over there, but we'll use one of these forces. So these, I don't want any other forces acting, just the suction scale. Okay, so, and we can use this fall off, this ramp that we provided. Okay, so I'm going to drop another here, and then the suction is very strong, and then here it drops down at the end to nothing. Okay, so this value I want it to be at the end, and 0. This one position about 0.25 and a value of 1, I think. There, value of 1, oh, not 10, 1. And then this one, this will be 0, value of 0, and a position 0.2. Okay, so this will give us a curve based on the distance, you know, from the outside of this kind of capsule shape to the inside there, and then we'll get a suction of the agents into the middle, right? Now, a couple more things I want to add. I'm going to add a pop force, just like we used in the previous project in the airplane, right? So again, turn off ignore mass. Let me think. I think I forgot to turn it off here. It's important because that will give you a dramatically different result. And so some amplitude, a swirl size, so a bigger effect again. Okay, just to break up the what's going on a bit there. That should be fine like that. And then a pop drag, just to so that the agents have a bit more of a natural, you know, kind of movement in the air, bit of inertia, and again turn off ignore mass there. Okay, so I think that is everything. Jump back, excuse me, jump back out here, turn off that delete, jump into our camera. Maybe I'll just create a quick ground. Just do a grid from here. Okay, make it big. Where is it? There we go. Okay, just something to see. Push the lighting up, crowd source, and let's make this full scale. And I'm just going to run a full flipbook with this and see how that comes out. So that I think is everything set up perfectly. We might need to delete some agents at the end. I'll do the full 200 frames, why not? And let's take a look. So let's check out the flipbook. So we'll play that through. So we can see the agents getting sucked in there. They're a bit hard to see, but you can see they're in there. So it depends on your render, how visible they are, how work on the density of the tornado. We've got the agents coming up here. You can see them going up onto the steps. I think you can see them colliding with the buildings a bit. Do see a few passing through there, the buildings. So I think I might go ahead and just delete those. Okay, yeah, there's quite a few running into there. Or maybe I'll go ahead and I'll go back and look at the avoidance force and increase that a bit. Okay,